Okay, today we are doing the ambiguous case that is linked to the sine rule. Okay, so what does it mean? When do I have to work with the ambiguous case? Now, the ambiguous case, it means that there are two solutions. Okay, now when do I have those two solutions? So if two sides and one angle of a triangle are given, and the side opposite the angle is shorter of the given two sides, two different triangles exist. So what is the key words there? The shorter side opposite the given angle gives me two possible answers. Okay, so very important is that both options must be calculated throughout the question. Okay, meaning that you'll have an acute angle and an obtuse angle, and that will influence all the lengths of sides that you are calculating in both, and all the remaining third angle that you will have to calculate. So let's have a look. If I give an example and I say to you, solve triangle PQR in which Q is 91 millimeter, R is 73 millimeters, and angle R is 49,5. Okay, now first of all, I don't see any right angles, so I am now not allowed to go and label any sides. Okay, but what I do see is two given sides and an exterior, well, not included angle, which means by highlighting that, I should realize that I can work with the sine rule. Okay, that is the requirements I need for a sine rule. Right, but I first need to check that out of the two given sides, this is the shorter side, that's the longer side. Which one is opposite the given angle, the shorter or the longest? The shorter side. That means this is an ambiguous case. Okay, which means I'm going to have two possible answers throughout. All right, now because I've identified the sine rule already, I can say that the sine of R will be over side R. The sine of Q will be over side Q, and the sine of P will be over side P. Okay, so sine of R is sine 49,5. The length of side R is 73. Sine of Q, I don't know, but the length of side Q is 91. Okay, so I can say that 91 sine 49,5 over 73 is equal to sine Q. That means Q is going to be shift sine of this entire thing here, and it works out to be 71,4. But what do you know? But Q can also equal the obtuse version of that, and therefore Q can also be 108,6. So there are my two options. My first option, I have to work with Q is equal to 71. My second option, Q is 108. Okay, so now we have to do two versions of this. Okay, so this means basically that I have 73Q91R, and this is 49,5. We just worked out that is 71,4. That means I can get angle P is going to equal 59,1, and my reason for that is sum of angles in a triangle. Okay, but I also worked out that Q can be 108. Okay, therefore, on this side, P will be 21,9, sum of angles in a triangle. Okay, so now I have done 1, 2, 3. Now I need to find out the length of RQ, or in other words, the length of side P. Okay, so the length of side P, so sine R over side R is equal to sine P over side P. But I just saw P can also be two options, so I will have two answers. So my first option is where I will have sine 49,5 over 73 is equal to sine. My first option is 51,1. Okay, and my second option there will be sine 49,5 over 73, but P can also be 21,9, and I can calculate P. Okay, so cross multiplication, P sine 49,5 is equal to 73 sine 59,1. Divide both sides by sine 49,5, and P works out to be 82 millimeters, or P sine 49,5 is equal to 73 sine 21,9. Divide by sine 49,5. P works out, it can also be 36. Okay, so that is what the ambiguous case means, that it can be acute or it can be obtuse. All right, so that is the first example I want you to do. So let's look at the second example. And the second example is part of exercise 11.5 that you will find on page 310. And let's look at the example, well, 1C as an example. So they say in triangle PQR, in which P is 38,3 and QR is 52 and PR is 74, and I need to solve all the lengths of sides and all the angles. Okay, so let's have a look. So I'm going to draw a triangle, and I'm going to say that's PQR, which means that's side P, that's side Q, that's side R. Angle P is 38,3. QR, which is side P, is 52 millimeters, and PR is 74 millimeters. Right, so I need to find the missing sides. Now I can't use sine, cos, or tan because I don't have a 90 degrees. But what I do have is I have two sides with an angle that is not included, and the moment I can highlight those, I know I can do the sine rule. So what does the sine rule say? The sine rule says that sine P over side P is equal to sine R over side R equals to sine Q over side Q. So I can say sine 38, 3 over 52 is equal to sine R over R. I don't know anything about that, but I do know that side Q is 74. So if I work with these two, I see that I can say 74 sine 38, 3 over 52 is equal to sine Q, and then I can work out Q by doing shift. So shift sine, I'm going to put in a fraction, 74 sine 38.3 over 52, and I get Q is 61.88 degrees. Okay, so if Q is 61.88, that means R is going to be 180 minus 61.88 minus 38.3, and that gives me 79.82 degrees, sum of angles in a triangle. So that's 79.82. Right, so that means I can now go and use sine 38, 3 over 52 equal to sine of R is now 79.82 over, well, that's QP or side R. Okay, so QP sine 38, 3 is equal to 52 sine 79.82. Divide both sides by sine 38. So I'm going to have 52 sine 79.82 over sine 38.3. And my answer is QP will have a length of 82.58 millimeter. And there I've solved the length of the sides and the size of the angles. Okay, so let's do another one. What if I have triangle FGH, and F is 121.2 and GH is 70 and FG is 50. Okay, there is a problem. I'm going to go back to this one. Just hold on. Scratch the second one. I did not check something. What did I not check? Yeah, I'm listening. I did not check if this is the ambiguous case or not. Okay, so there's my given angle. That's my longer side. This is my shorter side. The shorter side is opposite my given angle. So I need two options. So I'm going to keep this here. Luckily, I realized my mistake. I'm just going to zoom out a little bit more. So I had the following. I got Q is 61.88. What must I have done? I should have said, hold on, Q can be 180 minus 61.88, which means Q could have been 118.12 as well. So all of this that I've worked out, this QP I worked out was 82 58. So I worked out R is 79,82, and I worked out QP. Now I have to do the same for when Q is 118. Okay, so if Q is 118, it means I currently have this. P 38,3, Q 118,12, and R I don't know. So R I could get by saying 180 minus 38.3 minus 118.12. So R could also be 23.58. Okay, which means that I could have had sine 38,3 over 52 is equal to sine 23,58 over side QP. So QP sine 38,3 equals 52 sine 23,58. Okay, divide both sides. So QP 52 sine 23.58 over sine 38.3. Oh gosh, I didn't close the bracket. Let's try again. 52 sine 23.58, close the bracket. Sine 38.3, close the bracket. QP can also have a length of 33.56. Okay, so don't do the same that I just did now. Okay, sine rule, make a note. Check ambiguous case. It's so easy to forget that. Okay, let this be a lesson for you. Right, let's have a look at the second one now. So I have F, G, H. Don't know how it looks like, I'm just drawing it. F, G, H. G, H is 70, F, G is 50. So now I have to check. What did they give me? Two sides and an angle that's not included, so I can do the sine rule. But with that check, I now have to check the given angle is opposite what? Is it the longer or the shorter side? It's opposite the longest side here. So this is not the ambiguous case. That means I will use the sine rule once as I go on. Okay, I won't have this second option like I had here. So that was option A, that was option B, because the angle was opposite the shorter side. In this example, I don't have the shorter side opposite the given angle. I'm only doing one calculation for each side and angle. Okay, so sine of F over the length of F equals to sine of H over the length of H. So sine H is going to equal 50 sine 121,2 over 70 shift. Okay, and brackets 50 sine 121.2, close the bracket, over 70, close it. I get H has an option of 37,66 degrees. There is not an option 2 because we are not busy with the ambiguous case. Okay, so I just worked out that this is 37,66. Can I find the third angle? Yes, I can, because now I can say 180 minus 121.2 minus 37.66 gives me an answer of 21,14, because that's sum of angles in a triangle. That means I need one more side. So I have sine 121, 2 over 70 is equal to sine 21,14 over side G, which is FH. That means I will have FH sine 121,2 equals 70 sine 21,4. 14. Divide both sides. So I have 70 sine 21.14, close the bracket, over sine 121.2, close the bracket, and that gives me FH will have a length of 29,51. All right. So remember, to conclude the lesson, whenever I have two given sides with an angle that's not included, that is sine rule. But now I have to check, is the given angle opposite the shorter side? If my answer is yes, I don't have one version, I have two versions. Okay? If the angle is opposite the longer side, okay, that means I only have one solution going forward. You are now going to do exercise 11.5 on page 310, number 1A, B, 2, 3, and 4C. Thank you, grade 11s.